Transformation of sine function. Question 1. Write characteristics of sine function y equals to sine x. List key points for sine function. So let me first sketch one sine function for you. So this is a very rough sketch which I am going to use in this set of videos. Sine function is like this. Now here, let us say this is my x-axis and I've drawn just one wave and that's my y-axis. So it starts, wave starting from 0 to 360 degrees. So that is its time period. So one characteristic of this is time period. We say time period is equals to 360 degrees, right? Now, in this one full wave, it starts from the origin, that is your y-intercept. So we have y-intercept is at 0, 0, the origin. And then it goes to the maximum value of 1 at 90 degrees. So we have a maximum at 90 degrees and the value of maximum is 1, right? And then we have x-intercept at 180 degrees. So we actually have three x-intercepts. So we have x-intercepts at 0, 0 and then 180 degrees. Oh, I should write 0 and 180 degrees. Let me write it again. Yeah, that's correct. 180 degrees, 0. So let me write. And also at 360 degrees, 0. So y values are 0 at x-intercept. So we have x-intercepts at 0, 180 degrees and 360 degrees. And then we have minimum value at 270 degrees. And the value is minus 1, correct? So if we have minimum at 270 degrees and the value is minus 1, correct? And one full wave with a time period of 360 degrees. And that is how we can kind of describe our sinusoidal function here. Now the other parameters are, this is periodic and therefore domain is all real numbers, right? And how about range? Let's look into the range now. Range is from minimum minus 1 to maximum 1, right? So range is y belongs to real numbers, so that y is from minus 1 to plus 1. So that is the range for our function. And this line, which is kind of symmetry, we just call this axis of symmetry. Is y equals to 0. So these are major characteristics of our sine function. In the following videos, we will discuss transformation of sine function. So we'll start with vertical stretch, vertical translation, and things like that. So if you translate this wave up and down, you will see the y values will change, not the x values. That means maximum will remain at 90, but the value will not be 1, but will be 1 plus or minus, depending on by how much it translates up and down. So the y values will change. If we horizontally compress it, then the y values will not change, but the time period will change and the x values will change. If we dilate it or if we stretch it vertically, then the maximum, minimum values and the range will change, correct? So that is going to be the effect which we will observe in the following videos. Now I am doing it for sine function. I'll appreciate that when you do this exercise on sine function, then you take your function y equals to cos x, correct? And write all these characteristics or do a question parallel to what we have done for sine function. So replace sine function with cos function and redo the question. So that way you'll get more practice, correct? So I'll encourage you to draw better graphs than this. Take a graph paper, draw the graphs, and then answer the questions by replacing sine with cosine. That is going to give you more practice. Thank you and all the best.